So, my name is Elia Lema. I'm from and composite repair. Right now I can see few people. I think you can spend maybe this time to introduce ourselves while giving others time to join as well. So without further ado, from my side, I have Mr. Humphrey and Mr. Francis. Francis, please, can you say something? Thank you, Mr. Humphrey. Mr. Humphrey and Francis, our team, their communication and branding coordinators. So maybe I'll give this floor to other members as well to introduce themselves. Can I start with Mr. Stevens? Please welcome. You can introduce yourself and say where you're from.
Yeah. Good evening once again. My name is Seven Sadenga. I'm a civil engineer and I'm a freelancer.
Thank you so much. Can you go to Suzanne? Or she's not online. Any other person can introduce? Uh,
My name is Bakaeli. I'm the senior civil engineer, and I'm working with a national company of Tanzania. Thank you.
Thank you so much, Mr. Barakaya. You're warmly welcome. It is our pleasure to host you. May I welcome Misana Marima.
Okay, thank you. My name is Misana Malima, oil and gas engineer. I'm a freelancer. Thank you.
Thank you so much. Any other member? Beatrice, Kisha, please, can you say? Okay. We're just using these few minutes to introduce ourselves, so as to give a room for others to join as well. Mr. Raymond Dominic. Okay. Okay. Thank you, everyone. I think that's it. We'll be proceeding from our end, just to save time as well, because we only booked 1 hour for you guys as well. So I'll be sharing my screen so as we can be on the same page. Yes, I hope you all can see my screen. Francis, you be telling me if there's any person raising his hand, because I've been my presentation mode. That I think that would be convenient. Yes. Presented today. So the objective of this webinar first will be to raise awareness on metal composite repair and its benefit and the technology which is moving, but also to showcase our solutions on pipeline rehabilitation or repairs. So for those who are not, can you all hear me? Because we had some technical difficulties from our end. Please, anyone?
Yes, I can hear you.
Okay, and can you also see my screen that I'm sharing?
How the screen is not yet seen.
Okay. We apologize for that. I hope now. I hope now you can see my screen.
Yes, yes.
Okay. So just because I didn't know where we got off, I'll be starting afresh. I think that will be the best for all of us. Okay. Please, anyone, you can just respond if you have any difficulties seeing my screen. You can just raise your hand and say something. So the major objective of this webinar will be to raise awareness on composite repair, but as well to showcase our solutions on the same regard. So Solutions Tech, we're an integrated energy service company, and our major mission or vision is to create a better tomorrow in energy sector. And we have 5 different portfolios: assets integrated management, we have HSC solutions, oil and gas data management, well services together with training. So today we're going to be diving into deeply into asset integrated management, and the major focus in that is to make sure that our clients' assets are available and operating in good conditions, reliable in the sense that you don't have any shutdowns, and also which can be repaired. So how do we achieve that? Number one is to perform inspection, which we use two major methods. Number one is drum inspection, but also we do pigging or pipeline inline inspection. And for the case of repair or maintenance, we do composite repair, as which we're going to be seeing today. So just to dive in deeply into composite repair, nutshell is a combination of two different substances having different chemical and physical properties. And you combine them for the major case of getting a different compound or substance having different results. Maybe it could be stronger, or it can be chemical resistant. They are fluoride. So sodium in itself, it is very active. Chlorine gas, it's very toxic. But once combined, you get a table salt which is safe for consumption. So that is the meaning of composite. And when it comes to composite repair now, is the use of resin polymers together with fibers for the purpose of reinforcement, improving operations, emergency response, protection, or replacement of assets such as pipes, tanks, fitting, and pressure devices, which we're going to see. So the component of these resin polymers, uh, they are likes of epoxy resins, if you have heard of them. That's one of the examples. But when it comes to fibers, we have several. For instance, we have Kevlar, we have carbon fiber, and also we have glass fiber. So what are the user cases for composite material? Since they employ the use of this, several, for instance, aerospace or transportation industry, automotives, construction, marine, renewable energy, sports, medical, and oil and gas. So just to get a glimpse of these use cases, for instance, in aerospace, this is just a, a composition of the materials which are used for the construction of plane bodies. Now, they're not all which use the same materials, but this is just, for instance, Boeing, this is the combination of materials. The composition, which takes the larger percent, is composite. And the major reason for this is because composite, it is a lighter material, but also it is strong. So it does not compromise the integrity of the plane by using, rather, it helps in reducing the total load of the plane, which is the major strategy for the planes to take a lot of passengers or loads to reduce its own weight to begin with. Also, when it comes to automotive industries, for the high-end cars, for instance, they use composite material as well, as you can see from this picture. The blue on this pass, the blue color is is the composition of composite materials which are used for each and every part. So you can see for this vehicle, for instance, composite material is taking a higher composition in the design and construction on the same. Also in construction industries, for instance, there are composite panels which are used as well. Now we have, due to the challenges which are faced in this reinforcement bars, there's another invention which they use composite material to make these iron bars. So the good advantage of this is that they have the same or even higher strength bars. They are lightweight, so they don't increase the weight on the structures. They cannot be corroded because they're not made up of metal. So this is where the industry now is have. In energy, oil and gas industries, we have composite made pipes, and we're going to see how it is being done. Today we'll be talking mainly on the pipeline composite repair. So this, of course, this is the new technology. It has not been used at a larger percent in Tanzania. So it's something which we're going to introduce to you guys. But for external, for the other countries, something which has been done for quite some time now. So for our composite repair materials, of course, this is there are standards which they guide us for the application or the repair, but they are tested and approved by both ASME and ISO as well. And they have several features. Just to mention a few, our composite repair can hold up to 200 bars. It can withstand up to 150 degrees Celsius. The repair life it can go up to 20 years. So it is resistant to harsh environments. Once you install it, it is not being corroded by weather, water, or oxygen. And also it is unreactive to chemicals. Mostly all the hydrocarbons are unreactive to the repair as well. So before I dive into how it is being done, just to check on the conventional means which we use for pipeline repair and the challenges which we face. For instance, for quite some time, people have been using clamp for repair. For instance, some places leaking, so they introduce a clamp. So the major challenge with this is that it is heavy. So that means for mobilization or installation, it requires a lot of lifting. But also, it is introducing another weight to the pipeline, which is also affecting its integrity as well. The cost of this is also high because you have to buy custom-made clamps with different shapes of the pipelines or the size of pipelines. So also because you're using the ones which are bolted, for instance, that means you are subjecting something which is metal, which is susceptible to corrosion as well. And also for complex shapes, it is difficult to install this type of clamps. Another conventional means is to replace the part which is affected. Of course, for this one, that means you have to shut down the operations. You have to do the hot work, which is also has its risks. But you have to. It is cost because you have to get welders to do the job, and also time consuming. So these are one of the challenges for this. Same applies for metal sleeves, which you have to go to the affected parts. You install the sleeves and do the hot work welding. So it has the same or similar challenges compared to others. It is expensive, time consuming. You have to shut down the operations and also to do the repair. So that's where our technology now comes in, utilizing composite repair as means of reinforcement or repair. So contrary to the conventional means, composite repair requires few laborers to all operators to install. Does not require shutdown. It is cheaper compared or economical compared to other means, and also it saves time because in install to for 30 hours, so it saves time. So and our composite materials are made up of Kevlar tape or fiber, which we talked about the components area. We have fillers, and then we have bipox resin, which are the polymers. So you mix these two, and the fibers you get something which is stronger. So these are the steps which you use for composite repair. Number one, first we have to get the defects properties. That means the size or dimension of the defect, the position is internal, external. What's the environment of the pipeline? Is it offshore, onshore? What is the design pressure and temperature? What is the design life that the client wants as well? So once we get all this defect from the information from the client, we use our software to design the composite repair, length, and the number of wrapping. So after that, while on site, what we do, we perform surface preparation using a Bristol blaster. The major purpose of this is to remove the wrapping if there's any wrapping, and also to create a desired roughness so that the epox can stick well to the pipeline. And then we apply a filler just to get the original shape of the pipeline. and then we mix the bipox resin so that we start to perform the wrapping on the next step. So after that, monitor the curing it should be okay now for operation proceed at design pressure without any challenges. So these are some of the information that we use when we're designing the composite repair methods or the type of product that we are going to use, because we have several we're going to use to see later. So for instance, we have different type. Is it our characterization? Is it geometric, such as dent, buckling, or a bend? Is it corrosion or metal loss? Defect dimension. What's the length of of the defect? What's the width of the same? What is the percentage of metal loss or the metal loss on the with regard to pipeline thickness? The environment of the pipeline, is it onshore or offshore? Because we have different products for different environments. The operating parameters of the pipeline, what's the pressure, what is the temperature, the medium that is current operating on the pipeline. For instance, is it natural gas? Is it liquid? Is it water? Is it clean fuel? Is it crude oil? Is it acid? Because we use this to see if the medium is corrosive to the composite material that you're going to use. But a normal position as well, is it internal, external corrosion? And what's the repair life that the client wants? So our product can sustain up to 20 years repair life. But if client wants maybe after 5 years to decommission the pipeline, we can also design on the same. So, and also what's the pipeline grade that is currently installed? Is there an inspection record for the pipeline and the construction class or safety factor during construction? So these are some of the information that we use. These are the minimum. Depend on the type of clients. We also customize this type of information that we need. So let us see the use cases for composite repair, where it can be used. So for instance, for complex shapes such as this, which is seen in the picture, it is difficult now to install a clamp or to perform replacement of the joint or welding because of the environment. So now here's where composite repair now uses its advantage compared to other means. So you just have to repair or perform wrapping, being guided by the shape of the fitting. Also, we have stop kit, which in emergency leakage, it can be used for both onshore and offshore environments. This can sustain up to 50 bars without any issues. So the method of installation is very easy. We can have them in house also. If a client wants to have them, we also supply the same, so that once there's any emergency leakage at the press, he goes and install this very quickly. We have also subsea offshore repairs. Our products can be used for offshore repairs as well. And in this environment is where composite repair uses its advantage to the fullest, because you don't need, if for instance you require hot works, it won't be possible and also to be cumbersome in such environment, unless if you use special instruments. But for composite repair, you use the same means to apply. So these are also some of other user cases. We have, for instance, external corrosion or pitting. You can see internal corrosions. We have leakage. We have dents, cracks, and also through holes as some of the user cases. Now, at this point, please can you also confirm that we're on the same page? Anyone, please, Mr. Stevens, Raymond, Misana. Can you all hear me? Mr. Barakari, you can hear me? Anyone?
Yes, we are you.
Oh, okay. Okay. I think it is good if you can get a response from you guys. It will be better. Thank you. Thank you so much. So let me proceed. So these are the user cases for composite repair for different defects and environments that we apply these solutions and we get the results needed. Also, other user cases, it is in pipe support. So we have, these are some of the challenges that clients faces on their supports that we find due to different methods or retention of water uh, and the clamping system used. Then there's corrosion on this metal-to-metal contact. So we have a solution which we call it roller kit or pads. So we apply it on the support or on the pipe itself. And what you get is a 20-year lifetime without any corrosion on the supports. So as you can see, we can apply on the pipeline, and then you can put on top of the support. So there's no contact between the pipeline and the support. Or it can be on the support for the pipelines which are moving, which are not stationary. So these are some of the user cases for composite repair. So let's see some of the case studies that have been done. This is in Tanzania. So we had a client with an 899 the defect was big. So we did him. The pipeline was buried on the ground pipeline. So after excavation and verification of the defect, we perform cleaning, as I said earlier. We apply the filler, followed by wrapping. So after this, as per the design, the client is able now to operate on the same design pressure of 99 bars without any fear or any integrity compromise. Another case study, maybe you can see it is from yes, apologies, unfortunately, my network position at the network show. Okay. Okay. Let me proceed. So the benefit of using composite repair. So I think by now most of these benefits we have I've already discussed with you from the beginning. So the composite material reduces the cost of repair by 40%. It can be more or less depending on the situation or the extent of defect. There's no shutdown required during repair, so the operation proceed as usual. The installation time is minimal. In 1 hour, 2 hours, the installation will be done. For pipe sizes can be used, and it is flexible around complex shapes as we saw earlier. It has high tensile strength in comparison to steel as well. We're going to see that there's no creep with time, meaning that it does not degrade with time. And also another advantage is that there's no any hot work required during the repair, so um, there's no any risk introduced to the repair. It has a lifetime of 20 years, and also there's no any heavy lifting required during the installation. So just to get a perspective of how strong Kevlar is, I think you can all see the video from the right. So this is the comparison of 10 millimeter steel rope and Kevlar fiber or Kevlar rope. So they introduced this to a pressing machine and trying to stretch until it snaps. So for the steel rope, it goes up to around 4 tons. Then it breaks. So in the same comparison, using Kevlar rope, which is also around 10 millimeter, so we're going to see its yield strength. So of course, on the first attempt, it is not the rope which breaks, it is the clamps. And then on the second attempt, so it is already past 4 tons as compared to steel rope. Yeah, so you see it's around 6 tons is when the rope breaks. So with the same weight to size ratio, Kevlar is stronger than compared to steel, which is the fiber that we use in our composite materials. So that's it for me today. Please, I would love to welcome anyone with a question to just ask and see how we move from there. Please, you are welcome for any question. Any question from the attendees? You're welcome. Okay, that's it from our end. I think for any inquiries or question clarifications needed, you can contact us through the email which is seen on your screen and also the phone number. So after that, thank you so much for your time. Until next time.
Thank you, sir. Thank you.